Okay. Hello, everyone. Thank you for coming today. I'm Nori Shinoyama, lead of developer relations in Epic Games Japan. Today, I'm going to share our UE5 graphics knowledge gained from supporting various developers in Japan. But first, some people might not know how widely Unreal Engine is used in Japan. So let me show you some examples. There are Japanese games made with Unreal Engine. So as you can see, from realistic graphics, such as Square Enix Final Fantasy and Kingdom Hearts, to stylized graphics, such as Persona 3 and Hi-Fi Rush. And in Japan, Unreal Engine is used in many 2D animations as well as games. And I don't know how to pronounce the name in English, but we call it Precure in Japanese. It's one of the most popular anime in Japan. And UE is used for the ending movie, including all characters animation, like this image. And actually, we published a blog of this workflow and how they achieved this unique stylized graphics on that Unreal Engine 4. So if you are interested in the details, please take a look at this blog. And the Unreal Engine began to be used in manga and comics. And this is maybe a good example of how the Unreal Engine is used in comics. In this manga, the layers were decided using Unreal Engine, and the background images were rendered with Unreal Engine. Of course, then retouched. So if you are interested in stylized rendering, I talked about stylized techniques last year at Unreal Fest Gold Coast 2023. So you can find my presentation video in the Epic developer community. Did anyone see my presentation last year? Oh, thank you very much. Thank you. But today's topic, is more focused on realistic graphics and performance optimization things. Oh, anyway, so there are various contents made with UE in Japan, and when it comes to gaming market, Japan is mainly console market, not PC or not mobile. This means that very strict optimization are always required in order for their games to run smoothly on PS5, Xbox, and Nintendo Switch. And we have a lot of custom licenses. In that case, the custom licenses means paid support customers. So Epic Games Japan has 5 developer relations engineers dedicated to Unreal Engine support. So today, I would like to talk about what our team have faced since UE5 was released. So to explain it, let's look back at the demos that Epic has released. I know everyone knows this demo, but this is the very first demo of Unreal Engine 5. And this demo introduced Nanite, which can render infinite polygons in real time. And Lumen, which allows high-quality global illumination in real time. You can achieve this high-quality lighting just by putting a directional light and a skylight. So you don't need bake lighting anymore. And the following year, we released the T-sample demo, which introduced a world partition system. You can walk around in this big city in real time. And last year, we also released a demo called Electronic Dreams, which shows procedural generation over big forest. So such high quality demos have attracted so many developers, and they started using UE5 with really, really high expectations. I don't need to care about poly counts anymore. I don't need to bake light maps anymore. And I can use a variety of super high quality assets for free, like megascans. And also, I don't need to put assets by myself. We can now a PCG and also world partition. So on the other hand, careful developers noted these kind of comments. In the first demo, there is no grass. There are only inorganic materials like rocks and metals. And CT sample demo, have you noticed that all the trees have no leaves? that's why the season of the city sample is autumn. But Electronic Dreams demo has grass and leaves. But the required PC spec are really, really high. There is more. In the city sample, the reflection of the character is completely black. I hope you can see this, okay. And this is a very important point. You cannot enter any buildings in the city sample. So what have developer relations in Japan done since UE5 was released? I would say maybe it's clarifying the boundaries of our customers' vague expectation for UE5. So today, the concept of my session is to share with you the current technical boundaries that we've learned from support to a lot of developers in Japan. And this talk, I'm going to focus on real-time rendering, especially in terms of limited hardware like consoles. But I think this is also helpful for VFX or VP users as well. So here is today's agenda. Introduction will be over soon, but then I would like to share 3 big technical categories that Japanese developers faced when they started using UE5. And yeah, sorry, this is a very important disclaimer, so I put my script on this slide directly. So in this presentation, there will be a lot of talk about UE doesn't support it, and this is really difficult, but of course, I don't mean to imply that UE5 is useless. You don't use UE or something. So I just want to talk about the current limitations so that you can understand and take advantage of what UE5 is good at. And of course, UE5 evolves at a tremendous pace, so most of the current limitation may be eliminated in the future, I hope. So who I am? I'm Nori Shinoyama, the lead of developer relations, and I've been working at Epic Games Japan for more than 8 years. And before Epic, I worked at Sony and the PlayStation team as a graphic researcher. And completely off topic, but I have an international sake sommelier license. So if you come to Japan and want to have sake somewhere, feel free to reach out to me. I can introduce you good bar or restaurant serving great sake. And sorry, actually I did the same things last year here, but please give me 1 minute to show you button girls. I know that K-pop is really popular all over the world, but I really want everyone to know about J-pop idol as well. This button girls group is very unique Japanese idol and combines Japanese old traditional music and with current dance music. And actually, they sang their singer the ending song for Dragon Ball. So I would appreciate it if you take a look at them seriously. Sorry, let's get back on track. Okay. The first topic is multi-frame processing. Unreal has various processes that reference multiple frames or distribute the process over multiple frames. So let's start with anti-aliasing. As GPU performance increases, but the required resolution also increases. Therefore, outputting a high resolution is always a major issue. This is a CT sample rendered in 4K native with a certain GPU. In this case, it is 57 milliseconds, which is lower than 20 FPS. So because the amount of object increases and rendering techniques like Nanite Lumen more complex, so 4K full resolution rendering still is very, very expensive. And as many of you may already know, but Unreal Engine has an upscaling method called TSR, Temporal Super Resolution. And as shown in this figure, after the depth of field, internal buffer is upscaled to the target resolution by TSR. And here is a picture of 1080p upscaled to 4K with TSR. And this is 4K. And you may not notice much difference between them. 1080p, 4K, 1080p, 4K. However, TSR greatly reduced the processing load. We go from 57 milliseconds and 26 milliseconds. So TSR is very powerful, and since both Nanite and Lumen depend on internal resolution, it dramatically reduces the GPU load on Nanite Lumen as well. But in order to achieve this very high quality upscaling, TSR needs to refer multiple frames in the past. For this reason, this TSR has a few things you need to know. As TSR needs to collect a sufficient amount of samples to reach the target high resolution. And the first is a very simple example, but if the output resolution is identical to the target resolution, of course there is nothing to do, just use it. That's it. But as the internal resolution decreases, it becomes necessary to refer to past frames to reach and to gather like samples, enough samples to reach a higher resolution. And if the internal resolution is further reduced, it will be necessary to refer to older images to achieve a higher resolution. So an important point, if the frame rate is 30 FPS instead of 60 FPS, but still the same number of frames and the same number of samples are needed so to reach higher resolution. This means that TSR needs to refer to frames twice as old. So it works okay. This means that if the resolution is too low or the frame rate is too slow, the TSR will need to reference very old frames, and which can cause ghosting across the screen. This is an extreme example because rendering at 25% internal resolution, so you can see the while camera is moving, the entire screen is very blurry. However, like this, if the camera is stationary, if the camera is not moving, you can see that the TSR is producing like higher resolution like this. So it's a very strong point of like TSR. However, for any case, like ghosting can occur on the TSR whenever the FPS drops. In other words, even if the GPU or rendering cost is okay, the FPS can drop due to like a CPU animation, loading, or a game system. Yes. So like, though if the FPS drops, it can mean it can cause ghosting on TSR as well. So such CPU cost cannot be reduced by dynamic resolution. So if you want to maintain the quality of TSR, you need to optimize and keep all CPU, GPU performance stable. And there is a detailed document about the convergence of such TSRs on our official document pages. So, and it includes how to debug and how many past frames needs to be referenced. So I highly recommend that everyone using TSR should check this page. Furthermore, there is one more thing to note about TSR. TSR refers to multiple frames in the past, but the change across the frames is estimated with velocity. This means that TSR may not work correctly in areas where velocity is not written correctly. This is how the TSR would work if velocity isn't generated correctly. Like strong ghosting can be seen on the object, rotating object. This is a debug view to visualize velocity vectors. Like you will see that the object is rotating, but the velocity vectors are not changed. So this is the modified version, so that the correct velocity vectors are generated. So if the velocity vectors are correct, you can see that the ghosting disappeared. So how to correctly produce a velocity vector? So it's different for various situations. And Actually, I've published several articles on EDC, Epic Developer Community. But unfortunately, they are only available in Japanese. So, but I'm planning to make an English version soon. So please wait for it. But now there is more. Next, Lumen. UE5 is a real-time GI feature, Lumen, and there is a rough diagram of the Lumen process. Of course, we don't have enough time to explain each of them today. So I'm not going to dig into each part, but what I would like you to see here is the runtime calculation part of Lumen. You can see that Lumen calculates a lot of things in real time. So these calculations can be done in one frame. Now, it's still difficult. Lumen is designed to reduce the load on a single frame by distributing some parts of the algorithm into multiple frames. So the GI is computed, so GI can be computed in real time. So splitting into multiple frames means gradually and incrementally converging on the correct lighting. In this example, the ceiling is instantly closed to completely shield its skylight. But the entire screen was supposed to instantly go black, but you can see the GI gradually disappear. We are often asked by Japanese clients like how to reduce the GI delay. But unfortunately, currently there is no way to completely eliminate it in real time. Okay. Such GI delays are particularly apparent in emissive lighting. If you switch cameras in a scene, in a scene lit with emissive materials, you will see a very obvious delay like this. Sorry, you ignore this Nanite button, but at the moment the camera is switched, the lighting is calculated from scratch in Lumen, so it results in a very noticeable delay. This is one reason why lighting with emissive is still an experimental feature. Actually, we are tackling this issue, and we already implemented a solution only for real-time cut scenes, and actually it is already in UE5 mainstream. But sorry, to be more precise, like preload functions of sequencer finally supports Lumen scene calculation. So, but of course, it requires additional GPU cost, and still it doesn't support random camera switching like this. Let me summarize this part. So to maintain real-time performance, UE5 refers past frames and distribute processing over multiple frames. While this is a very powerful technique, it must be handled with the understanding that it has side effects, such as ghosting and delay. And yes, it's really important to understand that emissive-based lighting is still experimental. The night scene in the city sample is just a sample. So the longest section of this presentation is over, so let's move on to the next section. Next topic is virtualization and streaming. This section will focus mainly on Nanite. Nanite render very high-density polygon objects in real time. This is a polygon mesh that is actually rendered. And even if there are many objects, not just one, Nanite can render the high-density scene in real time. As you can see, most of triangles are so small and look like noise, and Nanite achieves details down to the pixel. Yes, which means triangles are often the size of the pixel. And Nanite is a UE term, but this type of technology is generally called virtualized geometry. And by virtualizing geometries and streaming them, memory load and GPU rendering cost can be dramatically decreased. This virtualization technology is also used for textures, and it's called virtual textures. So to understand virtualization, I think virtual texture is much easier to understand compared to Nanite, virtualized geometry. So let's review virtual texture here. This is a very basic, sorry, too simple figure, but when using normal textures, it was necessary to read the entire texture into memory. However, with virtual texture, it's possible to read texture partially, like this image. In other words, the advantage of virtual texture is that it can reduce texture memory consumption by loading textures for only the parts that are actually visible, and it can streaming out the parts that are no longer visible. And this virtual texture can also partially load a MIP map. This means that, for example, in a very large landscape, you can load a high-resolution MIP only for the areas visible from you, and load a low-resolution MIP for the area away from you, which has the advantage of greatly reducing the amount of high-resolution MIPs. So it's really good for memory consumption. Nanite can be described as polygon version of virtual texture. Instead of LOD, polygon objects are pre-clustered in order to create a hierarchical data structure. I think this is helpful for you to understand how Nanite works. I intentionally applied offset so that you can see the rough Nanite model. Of course, without the offset, these low poly clusters are only rendered at a really far distance from the camera view. So you cannot see them, you cannot recognize them. And I would like to just point out that whole building doesn't change, but clusters of the objects changes. And Nanite is so powerful, but it has the same limitation as virtual texture has. Before they start their streaming, both Nanite and virtual texture have to check which objects are needed and which parts of them are needed and how much detail of them are needed. This means that if you teleport or switch cameras in an instant, Nanite will start streaming just after the camera switches. So the polygons of some objects or textures, some MIPs of virtual texture, may appear really rough for a moment because they cannot be streamed in time. Yes, like this. Okay. And for cutscenes, where the camera cut is predetermined and objects do not change, you have a function called cinematic pre-streaming to counter this problem. Use movie render queues pre-streaming recorder to store what objects will be loaded in the cutscene in advance, and then by referencing the data at runtime, streaming data can be loaded in advance, so it can eliminate this streaming delays. So, but it's just only a measure for cutscenes. So if the camera randomly switches or teleports during gameplay, so UE is not prepared because UE does not know what objects to load in advance. So in such case, there may possibly be noticeable streaming delay. So you may need to implement fade-ins or effects to hide it. So virtualization and streaming summary. So in order to keep objects with huge data sizes in constant memory, virtual texture and Nanite utilize data virtualization technology. But they are loaded by streaming, so if the camera is moving quickly, the streaming may not be able to finish in time, and low-resolution objects may be visible. And we have a solution for cutscenes, pre-streaming, but however, like teleportation and other instantaneous camera switching is not yet supported, and requires maybe fade-in or other solutions. So let's go to the third section. The third topic is like utilization of existing assets. So we have Quick3 Megascans. Megascans is a library of 3D assets created like from real objects, and currently it's completely free to use only with the Unreal Engine. Yes, and Unreal Engine has a built-in feature called Bridge that allows you to drag and drop Megascans assets into your scene. So using these assets and UE5, Nanite, and Lumen, you can create scenes in real time while checking the final artwork. You don't need to render rough preview scene, and also you don't need to wait for a long time to get the final image of any other offline rendering applications. So you can use many existing assets like Megascan or Marketplace for free. Oh, only Megascan is free, but so actually many customers in Japan started creating scene using Quick3 assets and Marketplace assets. However, many of them run into problems and reached out to us. For example, there is something wrong with the rendering result, or GPU cost is really, really high. So here is a look back at the problem many Japanese clients faced first, and especially when using assets comes from Megascans. Yeah, I would call the problem as modular assets versus Lumen cards problem, and let's review the meaning of each first. Let's see how to build a big house. Modular assets are assets that are divided into parts, such as windows, walls, etc. So rather than a single big object, including all parts, rather than a single big object, including all parts of the house, you can build a house just by combining these modular assets. Next is Lumen card. In order to compute GAI quickly, Lumen covers each object with simple planes called Lumen cards, like this. And these Lumen cards are pre-computed for each static mesh. This is an example of virtualizing Lumen cards in the city sample. So you can see that Lumen cards have been set for various objects, from trees to cars. And so even complicated shapes like trees, their Lumen cards are pretty simple. Then Lumen cards can only, the Lumen cards can only be very simple shapes. So for example, if you create a complex mesh, such as a house interior in one piece, you will not be able to render an appropriate Lumen card, create an appropriate Lumen card to fit the shapes. So that means that an error will occur in the Lumen GI. The pink area in this figure are areas where Lumen cannot calculate shading properly because Lumen cards are not fit properly. So when using Lumen, there is a basic rule. It is there is a basic rule which you should make complex shapes using simple objects such as modular assets. However, there is a problem in creating with modular assets. The city sample building is made up for modular assets like this, but what if each of these modular assets has its own Lumen curve? This is such example. As you can see, a very large number of Lumen curves are generated, even for a single building. So the processing load and memory consumption would jump because of them. So it would not be possible to process them in real time. And of course, the actual city sample is not like this. The UE has the ability to merge Lumen curves of objects with the same IDs. The ID is ray tracing group ID of static mesh component. Objects with the same ID have their Lumen curves merged like this. Okay, this video doesn't work, sorry. Like this. So like this. And it does not matter if Lumen use software ray tracing or hardware ray tracing. Yeah. So in the city sample, the ray tracing group ID for each building is set to the same value, the ID. So the entire building is a single Lumen curve, like this image. This dramatically reduces the number of Lumen curves and allows for Lumen lighting with less GPU load. Great solution, but this solution causes the first problem. I first say that you should use modular assets because Lumen curves only support simple shapes, right? So even if you use modular assets, if you put the Lumen curves together, you might have areas like that the Lumen cannot calculate properly. So I think that's the one reason why all buildings in city sample, all buildings in city sample have their own Lumen curves combined. So there is no building like in city sample you can enter inside. Currently, like as far as I can see, there is no algorithm or Lumen mechanism that allows both the exterior and interior at the same time. So it may be necessary to create the exterior and interior of the building separately, but it may also be necessary to turn the visibility on or off of the interior of the building in the game logic side. So in order to reduce the Lumen card calculations of inside the building. So let me talk with one more issue. It's about leaves and grass. Nanite now supports masked in UE 5.3. This is really great. However, as has been said in various places, like Nanite masked material calculation requires really high GPU load. And it's still difficult to run them at like a 60 FPS or at high frame rate on console so far. So unfortunately, like for performance considerations, it may not be possible to use masked leaves and grass as Nanite objects. Then here is a suggestion that comes up. Okay, let's the rocks and trunks be Nanite objects and only the leaves be non-Nanite objects. Do you think that this really works well? Lumen and VSM are actually optimized for Nanite and will most likely handle Nanite objects faster. So let's look at example. In the previous section, we explained that each object has Lumen curves for GI calculation. And so how Lumen curves are calculated, this chair is covered by 6 Lumen curves, just like a bounding box. Sorry if it's hard to see. This is a render dock capture that shows how the non-Nanite chair is rendered in Lumen. Each card is drawn one at a time on the GPU hardware rasterizer. This means that if it has 6 cards, if the chair has 6 cards, the chair needs, Lumen needs to calculate 6 draw calls. But Nanite object, by using the software rasterizer of Nanite, Lumen can render the 6 Lumen cards at once. Okay, you can see, maybe you see this area, okay? So it should be faster than non-Nanite chair rendering. And similar calculation is performed by a virtual shadow map. So this is why people say, if you use Lumen and VSM, you should make objects Nanite as much as possible, even if the objects are really low poly models. So if your project uses Lumen and VSM and you want to place a large number of masked objects such as trees and grass, even if they are not Nanite objects, the GPU load can be still very high. Honestly, for this reason, some developers in Japan gave up using Lumen and VSM and opt for the old UE4 lighting method. And because they don't have enough time to convert their trees to polygonal shapes, leaves. So in Fortnite, all trees have polygon-shaped leaves and are rendered with opaque materials. So, but unfortunately, as far as I know, Quixel Megascans doesn't have such kind of polygon-shaped leaves so far. Sorry if my understanding is not correct. So let me briefly summarize this section. Unreal Engine has a large number of assets available for free, including Megascans. However, it's not always possible to make use of these assets as they are. And maybe they may not render correct result, and also it cause a very high GPU cost. So first you need to check the compatibility of your scene and the features you want to use. Okay, actually, I introduced a brief overview of the 3 points that Japanese developers, especially game developers, had trouble with when using UE5. Of course, there are many more detailed points to remember, and these are probably the top 3 questions or points we've received from so many developers in Japan. So lastly, let me wrap up this presentation. All of the Unreal Engine features are very powerful, and in order to prove they are practical, we provided great demos every year. But they are not a panacea, they are not a silver bullet, and have various limitations. Of course, we keep working on improving them, but you always need to understand current limitation. By designing your scene following the restrictions, you can achieve excellent graphics with stable frame rates. So I hope this presentation will help you clarify your expectations on UE5. Thank you for listening.